Hi. So, I don't have a touchscreen tablet, so I couldn't do it on my computer. I wrote it out myself. Um, and here I have the explanation. So let's go to that. Okay. So if you look here, oh wait, that was my previous recording. Whoops. Come on now. Unfortunate. Okay, I'm sorry about that. Here we go. So as you can see, we got problem number 2, problem number 5. We're going to start with number 2. So you have 2 points at a distance d apart, and of course the force that they feel on each other has magnitude F. So in order to double that, what would we change the distance to? Okay, very simple. If you look at the equation, you have force is equal to Q1, Q2 over d squared, right? And then a constant on the right. So we're just focused on d squared. We know that we need to get 2 on the other side, so we need to do something to d to get that 2 on the other side. And the way you set it up, you want 2 on this side, so you want d squared to be equal to 1/2 in order to have a 2 on top and cross out with that 2. I hope you can see my mouse through all this, but so d squared is equal to 1/2. Okay, and then we just solve for d. And d is equal to 1 over radical 2. Very simple. Number 5. When 2-point charges are 2 centimeters apart, each one experiences a 1 Newton force due to the other charge. If they are moved to a new separation of 8 centimeters, the electric force on each of them will be closest to. Okay, so this time I didn't put in the whole equation. I mean, this is the way I think of it in my head. I just know that 1 over d squared is proportional to F, and forget about all the other stuff. That's all I care about because it's not going to change. So, we know that we are going to change our separation from 2 centimeters to 8 centimeters. So we are multiplying it by 4. So when you plug that in to 1 over d squared, you are multiplying that whole side by 1 over 16. So 4 squared would be 16. 1 over 16 would now be on the outside and would have to then be on the other side as well. So if they are moved to a separation of 8 centimeters, which is 4 times as far, the force will be 1/16 as strong. And voila, there you go. Those are my 2 problems. I hope I win. Yeah. Okay, how do I do this? Okay, thank you, Professor. Wait. And anytime now.